Hey, Jim Bergmann with measureQuick, and here today with Ty Branaman from ESCO, and thought we would get together and just do a little bit of discussion on education, HVAC, and measureQuick, and just where we're at. Ty and I've had some pretty spirited discussions on maybe skilled and unskilled labor, or just labor in general. And Ty's pretty current in the educational space. I was in there for quite a few years, but I'm a few years out now, and I thought it'd be fun to bring him on just to discuss maybe some current trends, where we're headed, and what we could do. And I just want to start off with a couple of comments because I did a short the other day, and it was about measure quick and not having your technicians have to necessarily know how to measure superheat and subcooling. It's let them focus on using the measurement versus making the measurement. And the comments I got back were they were very special. And when your computer crashes, they'll be lost. The young generation can't use a calculator. They need to learn how to check superheat and subcooling. It's not rocket science. That's why the younger generation will never learn. Teach them the old way first and then let them try this. I disagree. Yes, make it easy, but it takes thinking out of it. If you know what's happening or supposed to happen in a system, you can easily remember how to do superheat and subcooling and vice versa. And they never, ever learn the basics. Nope. Old school still works best. Young guys are lost as much as you are. That was a little dig on me. So new techs won't know how or what they're doing. It makes dumber techs, unfortunately. Techs don't know how to make measurements before using the tools and apps. Learn it or go to work somewhere else. It's part of the theory to understand superheat and subcooling. Lame, lazy, not educated is why you use this. And I was thinking, those are some pretty pointed comments. And so I thought Ty and I could have a little discussion today just about what skilled labor is and just how we're going to fix some of the things in the industry. And I'll let you get some breathing room. Otherwise, I'm just going to dominate the entire discussion the entire time, Ty.
I think that's a great way to start off because I went through my first 10 years or so of being in a trade, maybe longer than that, before I really even understood what superheat and subcooling was. I could do the calculation. I knew to add or subtract refrigerant to get the numbers to match up, but I didn't understand it. And I find that there's people that can do the math, the calculation, that still don't understand superheat, what it really means, what's really happening. So the fact is that, hey, if we have something that can make that easier, and then, yeah, I would still ideally want everybody to understand the hows and the whys of it, but it doesn't mean it's going to get that job done any faster right now. So superheat and subcooling is massively important. I'm going to use an app. I'm going to find it the quickest possible. And by the time I do that hand math, it could already change. The system's changing and adjusting all the time. So I wouldn't go to an accountant and expect the accountant to do all of my math by hand just because he can. I expect that accountant to use some kind of a program, a computer that's getting that math information up to speed quickly, and it's saving me and him a lot of time and actually making it more accurate. So I'm all about technology, using apps. I was told in school that I had to do long math and you're never going to have a calculator with you. And they were wrong because I have a calculator with me all the time. And they said, what happens if you don't have your calculator? Then I usually just either ignore it or I'll try to do the math. But I struggle sometimes with numbers.
Yeah.
So to say that we shouldn't use technology is, to me, it's hard for me to grasp that because it's, to me, ridiculous.
And I think you got to ask yourself today, how skilled is the skilled labor in the HVAC industry? Because right now, if you just look at our industry in general, there's studies just done a couple of years ago by DOE that 50 to 70% of the systems in our industry have charge problems. 50 to 70% have airflow issues. 90 to 100% have at least one fault when you consider duct leakage in there, right? So we have all these people that are saying our skilled labor is skilled, but our stats show otherwise. And it shows that a lot of people need a lot of help. And I still think every year, you and I've both been to HVAC Excellence. We've gone to trainings and you're training instructors there. And you and I both teach fundamentals. And every single year, we're still teaching fundamentals and we're teaching instructors fundamentals because we see as we're teaching the fundamentals to instructors that the lights are coming on and people are starting to understand things that they never understood in their career. And I think you and I both have the same passion for it because both of us struggled with fundamentals. And I know for me, it was until I got into education. Like My instructor skipped chapters 1, 2, and 3. We skipped all the math. We skipped all the science. We skipped all the heat and heat transfer. We never did anything on psychometrics. And I learned all the mechanics of HVAC without learning any of the technical side of HVAC or the scientific side of HVAC. So I could take apart, put together anything. I could change any part of an air conditioner need changing. If a compressor went bad, I could swap it out. I might be able to tell you some basics about things, but I'm telling you, I did systems that were 70 to 700 tons. When I left HVAC, my background, 70 to 700 built up systems. I can tell you in my entire career, I don't know that I ever measured airflow before I was an instructor. I measured static pressure or things like that a few times on some big systems, but I never, ever measured airflow in my entire career. I had not ever measured capacity in my entire career. I had never measured efficiency in my entire career. And so I think they're not doing a root cause analysis.
So I think there is absolutely, without a doubt, a need for skill in the trade. I think there's a huge lack of skill that we have. We have people that are really good at fixing equipment, but they don't look at the whole house. There's people that are oversizing air conditioners insanely. There's still people out there that are just diehard beer can cold. There's people that think the unit should cycle off on the hottest part of the hottest day. And we can just go on and on with the need that we need more skill in the trade. But I still do believe that the people have skill. Like when I've taught classes, there's students that didn't know which way to turn a valve to open up a nitrogen tank. These are the things that we have to start with because they were completely unskilled. We had to start with which way do you turn a tank? Which way do you turn the valve? How to even put gauges on a system without getting burnt. So many of those little steps are still skills, but we in the trade have a major lack of skills all the way up to the top of it. Anytime you see somebody talking about sizing and they're putting in 1 ton per 2,000 square foot, like the internet just goes mad about that. How did you do that? It's nope, you're wrong. And one of the problems that we have is the old school ways, which were a lot of times just shortcuts. They keep training into the new people and it just keeps carrying on. It keeps the problem go longer and longer. And I hear all the time about the old school ways. And I got this Carrier book from 1964, and it talks about pulling a deep vacuum to 100 microns. It talks about flowing nitrogen and oxidation issues. So the stuff that we talk about isn't new. It's just we got away with it in the past. And now we're having to go back to those things. And people get so hung up on the way I learned it is the only way that it can be. And so we have to open up to how can we learn more stuff. And that's one of the things that I like about the measureQuick thing is when I teach class in school, I have this very long form and it takes the students like 4 hours to get a reading out of a piece of equipment. And it's false because by the time they get the reading from one side, it's changed by the time they get all the readings done. And measureQuick is able to do all of that work instantly, like immediately does all that information. So if they can hook up the equipment correctly, they can get a better snapshot of somebody that's potentially been doing this for 20 years. And I hear all the time people call for tech support and they give me pressures and I can't do anything with that. I can give you compression ratio. That's all I can do. And then finally they give you superheat or subcooling, but they never look beyond just these base numbers. With measureQuick, they're able to see the whole system. And not just that, I can look specifically at what somebody's telling me a problem is. Instead of them looking and saying, here's my superheat, here's my target superheat, and I'm having to compare numbers because my mind doesn't work in numbers, I can look at the green and red and yellow. And if these things are in green, I can go down to what's in red or yellow. Let me start there, and then we can go from there. And recently, as I get older, I had to go to the doctor, and I had to do some blood work. And there's all this stuff I have no clue what it meant. No clue at all. But I saw all this stuff in the green. I'm like, cool. And then I saw something in red. I thought, let me go check that out. Then it gave me the tools to start learning about what that red was. And then when the doctor came back and talked to you about it, I had an understanding what's going on. And it doesn't mean that those tests are making anybody's job less important. It's able to let us focus on what the real issues are. And I think with the technology that we have now, getting to take these numbers that are critically important and looking at a much bigger picture than just pressures or just superheat and subcooling, we can really see what's going on with that system. We're able to actually diagnose bigger problems than just, hey, it's blowing cold air. We can actually look at, hey, how can we get this customer comfortable?
Well, and I think that's where there's another comment that was something along the lines of all those other measurements you're making are BS. And it's really interesting because we're in a job of moving heat energy, right? And we design a system. Let's say we design a system and it's 2.5 2.5 tons. Well, and maybe we do a room by room heat loss calculation. Well, how many people actually make sure that the amount of cooling that they engineered the system to do is the amount of cooling that's being delivered to the house, and then the amount of cooling that's delivered to each one of the rooms, and make sure that they have an airflow that it was designed for, and within a certain static pressure that it was designed for. And I would say that it's probably almost nobody. And the problem is, until you use a software like measureQuick to actually look at capacity and look at efficiency, then you're in this vacuum of thinking that superheat and subcooling are like a be all end all. And you can have correct superheat and correct subcooling and not have near the capacity that you need because you have low airflow and you charge the system to the airflow instead of charging the system to its rated capacity. And in fact, if you were to get the airflow correct, you'd find out your superheat would start to go way up because now it's got more airflow. And a lot of people don't realize that. Primarily happens with fixed orifice systems. We still have tons of fixed orifice systems out in the industry. And so when we're looking at all these things, I think what we've got to understand is that as an industry, we've been fixated on the wrong things, right? We're fixated on, if you think about a basic technician is fixated on his gauges. What are the pressures? The first thing you want to do is gauge up. The gauges are your friend. First thing you want to do is gauge up, see what the pressures are. If you don't know what the pressures are supposed to be, what difference does it make what they are? And then it gets to the point, I'm to the next graduate level, I can get the superheat and the subcooling correct. Okay, that's really nifty, but what drives the heat transfer? It's coil temperature. So again, we're back to pressures. If you don't have the right pressures, but you have the right superheat and subcooling, you don't have the right heat transfer rate. And then almost nobody in this industry has tools to measure airflow. And that's another huge problem is until we get the airflow, you really can't get the charge right. And it's challenge after challenge, but I think we should spend a little bit of time talking about what's the solution? Like, how do we fix this? Because the question becomes I've been working with a contractor here locally, Chad Simpson, who's been hiring guys like out of Xerox industry. These are people with skills. When I say people with skills, they can operate a screwdriver. They can take apart a piece of machinery. They can read and use a volt-ohm meter. They can measure amperage on a piece of equipment. They can move heavy things around. They can understand complex mechanical systems. They have skills, but they don't have HVAC skills. And so he's taken 8 to 10 weeks, teach them how to take apart a furnace, teach them how to clean a blower, teach them how to clean a condenser, teach them how to change a capacitor, teach them how to change a contactor coil, doing some basic like low voltage trainings to understand how a low voltage circuit works and the line voltage circuit works, teach them how to program a thermostat and how to configure a thermostat. And they can do that in 8 to 10 weeks because, again, these are people with customer service skills and they're people with mechanical skills. But then the secret is they're giving a measureQuick, which is now taking my 30 years of experience, which we've built into an application, and allowing these guys to teach them about proper probe placement, which is like absolutely critical. They put 9 probes on every job, every time. Within about 8 to 10 weeks, these guys are out as PM techs. Now, they're not service techs. We're not throwing these guys into jobs where they got to figure out a low voltage short rubbing on a gas line. You're not going to do that your first day out in the field without probably making it your last day in the field. But they're out on systems that are working and they're able to identify systems that are operating poorly, systems that are good candidates for repair or for replacement. And so when we put this out there, it is like the world is coming to an end, that you cannot do this. This is anarchy. And I just want to get your opinion. I know you like technology, but when it comes to training, is it viable to actually let people use diagnostic tool that shows them what's in bounds and out of bounds visually without having to necessarily know what all the numbers are?
It's crucial to have that information to do that. I look back at systems that I thought I had done really well with, and I didn't have all the information or the ability to diagnose everything. It was like just using my limited viewpoint of superheat and subcooling, thinking, oh man, I did really good with that. And then later you start seeing that bigger picture, and it takes so many years to get somebody to understand that bigger picture and then to do all the math. Like, it's not profitable. There's no way you can spend all the time it would take to do all the math to get that bigger picture. So when I can have a tool come in, they can get that bigger picture and they can focus on just what the problem is, or they can call for help and just get a focus on what that problem is. And somebody can help walk them through those other steps. It's huge. We're not taking the skill away. We're empowering them. If I look at the auto mechanic, I wouldn't go up to the dealership and be like, hey, don't use that computer. Don't plug into that computer. I want you to go get your multimeter and go through and find out what the problem is the old school way. That's insane. If we look at auto mechanics, they use the technology. They use these tools that communicate with the computer and the system. And then they also use their skills to repair and fix the systems. I would never go to a mechanic and say, you're not doing things right because you're using a computer tool to figure out stuff or diagnose stuff.
There's actually, you stumbled upon something, but you didn't quite phrase it the way I might. An auto mechanic is a guy that changes your brakes, changes your oil, figures out what the squeak is underneath your car. And an auto tech, a technician, uses technology. They plug in a scan tool. They go through the electronics. They leverage technology. They're two distinct people within a service industry. When you go into a garage, if you need new tires, you're going to get a mechanic work on your car. And this is what I'm getting at, is our industry is absolutely full of mechanics. We have really good mechanics. When they walk up to a system, they pop the cover off. They see the compressor swollen or the capacitor swollen. Man, they can figure that out right away, and they can swap that capacitor out and they can get that system running again in a heartbeat. But when they go out and they have something, it just doesn't seem to be, it runs all the time, or it's not cooling enough, or I'm having trouble getting this upstairs room cool, or it used to work better, but it doesn't work as well anymore. When it's not something that's mechanical in nature, our mechanics struggle to find a solution because they go back to the same things. They measure superheat, they measure subcooling. They try and fix every problem on the air side with refrigerant. If I can just get the refrigerant right, the air side will magically fix itself. They clean evaporator coils, but they don't do a root cause analysis about what got that evaporator coil dirty. Do I have enough filtering? Is the air getting by the filters? How many times have you gone down and looked at open filter slots in basements, right? You have a guy go down there, he'll change the filter out, but he doesn't step back and look at that for a minute and go, probably should do something about that air getting around the front side of that filter, because that filter slot, the air doesn't know what side the filter's on. It's not going to magically just take all the filter air on the inlet side. It's going to take it on the other side too. So they're out there unplugging the condensate drain. Tell me condensate drains need regular maintenance. They're cleaning the evaporator coils because evaporator coils need regular maintenance. When was the last time you ever cleaned your evaporator coil in your car? I have never, ever had to clean one. You know why? Cabin filter. You know what? When the cabin filter gets plugged up completely, no air gets through it. No dirt gets through it. It doesn't get my coil dirty. And I know when I don't get enough cooling that it's probably time to change my cabin filter again. But the condensate line in my car never needs cleaned. I've never had to clean it. I've never had to clean my cabin, or clean my coil and my evaporator coil. I don't even know if I ever cleaned a condenser on my car as long as I've been driving my car. You would think driving through Cottonwood, driving through dirt, and I've got 150,000 miles on my Honda, that it would have needed a condenser coil cleaning or evaporator coil cleaning by now if it actually needed it. Going back to that whole thing is, what we're trying to do with measureQuick, and what people don't realize is you always need mechanics. We always need people to fix these problems. But what the problem is we need technicians to actually find them. And we need to find them before the capacitor blows, find them before the evaporator plugs up, find them before they don't have enough cooling to keep up. And that's what we're doing with measureQuick. And then additionally, like you said earlier, you can't do the calculations as fast as the system changes. That's a huge issue. So if you have a fixed orifice, so I'm going to give you some quizzes. I always like to do this to Brian Orr, right? So let's imagine the system's off for a minute. It's completely off. And we turn the thermostat to cool and we turn down the switch. So tell me, what's the first thing that's going to happen?
Contactor thermostat closes, connects R to Y and R to G.
Yep. And then what happens next?
Indoor blower relay is going to close. Indoor fan's going to come on. Outdoor contactor closes. The compressor and the condenser fan motor comes on.
Perfect. So how much cooling do we have at that instant, at that second, right when that contactor pulls in? How much cooling are we doing?
None.
We aren't doing any cooling. Yeah, so we're not doing any cooling, and then the system starts to stabilize and pressure start to get. So what's happening to the humidity in that house? As soon as that system starts off, we have temperature, we have humidity. What starts to happen in the first few minutes of operation?
Your cool temperature starts to drop. You're not dehumidifying anything yet. You're just sensible cooling as that air's moving through there. You're going to have to run it for 15 minutes or so before you finally start actually dehumidifying.
So now your coil falls below the dew point temperature. And then once the coil falls below the dew point, can we stop the moisture from condensing on it?
Cool. Yes. Too much air.
Not really. If it falls below the dew point, it's just going to start sweating. And then it's
You'll
going to
sweat.
start robbing it of sensible capacity, right? Because we're going to start taking the water vapor in the air and turning it to liquid water. And
Right.
so our temperature split, which might be normally 20 degrees, if it's really humid, it's going to be maybe like 15 degrees. And our temp split could be as low as 9 degrees and be totally fine. If we're at 80 degrees and 85% relative humidity, which think that's ever happened in Texas or Florida? Yeah, right. And now that system's running. We had a target wet bulb when we started, and we had an outdoor air temperature. But what can you tell me about if we have a fixed orifice system? What can you tell me about the target superheat? What's it constantly doing as the system is running?
It's going to be changing. As your indoor temperature drops, you're going to be changing about how fast you're blowing that refrigerant off that evaporator coil. As your outdoor temperature changes, you're affecting how fast or how much refrigerant you're actually pushing past that metering device. So it's changing constantly.
It's dynamic. The whole system's dynamic, right?
Yeah.
And we're trying to make static measurements on a dynamic system. Yes. We're looking at a picture. It's like trying to, if I asked you what was happening in a picture versus what was happening in a video, right? Which one's easier to describe what's actually happening versus what you assume is happening?
The video, you're seeing more of the picture.
Yeah, that's the whole concept, right? As we see what's happening in the whole system, we get a better picture of what's actually going on. And here's another interesting one. Have you ever seen extended performance tables on equipment?
Yes.
How often does a 2-ton system produce 2 tons of cooling?
Very rarely.
Under what set of conditions can we pretty much assure that it does?
Oh, the AHRA factory conditions. What is that? 85 degree outdoor day and an 80 degree indoor with 50% relative humidity or something like that?
Yeah, 95 degrees outdoors, 80 degrees indoors, 50% relative humidity. And usually that's based also at 400 CFM a ton. If we got like a variable speed piece of equipment, that means when it's operating at full capacity, right? And so the challenge with our industry also is how much cooling should we be doing? How much temperature split should we have? What should be our ratio of heat to humidity removed? Do our pressures vary on a system if it's a 85 degree day in-house, 85 versus 69 degrees? So the pressure is going to be different? Absolutely. We're going to be different from a 70 degree day to a 120 degree day outside.
Yes.
And so we have a variable superheat. We have a variable suction pressure, a variable head pressure. We have a variable subcooling in this case. We have a variable static pressure. A lot of times people don't understand static pressure actually changes with air density. And now other things people don't even know measureQuick is doing is a temperature pressure chart, right? Let's say you got a set of probes and you zero your probes and you're standing at sea level. And then you take that same set of probes and you go to Denver and you zero them at Denver. Is that the same zero? No, it's not. They're relative probes. They're not absolute pressure probes. So measureQuick takes into account the temperature and the pressure of the refrigerant and automatically adjusts the saturation temperature based upon your elevation so that you get a true zero, because inside of a refrigeration system is an absolute pressure. It's completely isolated from atmosphere, so the atmospheric pressure doesn't impact it. But when you have these relative probes and you zero your relative probes at altitude, they're not really being zeroed to the equivalent of zero at sea level. People don't understand that. Air density changes if you go up in altitude at all. And we're talking like, what's very interesting is we always talk about it really didn't have a huge impact till we're at, let's say, 2,000 feet is when we start to make adjustments. And Denver's Mile High City, which is 5,280 feet. Even at a few hundred feet, all these little nuance, all these little changes make a difference. So when we're talking about, we make corrections for your air density. We make corrections for your temperature pressure chart. You've probably used the sensible heat and the latent heat and the formulas, right? what are those formulas called? What's the general term for those?
But you got your latent heat factor and your sensible heat factor, sensible
Right.
for
But the
your,
latent, those are called what kind of formulas? If you're to
I don't
say
know
it's
the name of the,
standard air formulas, those are
okay.
all standard air formulas. So when we're talking about standard air, what we're talking about is air that has a defined mass to it. So it's 0.075 pounds per cubic foot. So that 4.5 comes from 0.075 times 60. It's a constant. And the 1.08 comes from the 0.07 times 60 times, I think 0.24, which is the specific heat of air.
Don't you have an
Those,
app for that?
yeah, the thing is those formulas aren't the formulas that are used to engineer equipment. Equipment's engineered with the ASHRAE, Hyman-Wechsler psychometric equations, which are called moist air equations. And those moist
I
air
didn't know that.
equations, yeah. So those moist air equations are what we use in measureQuick. And that's why, again, we're making all these corrections. That's why our software does so well at helping people diagnose a system, right? But going back to like technology, we take this young kid, we hand him technology. How many years, honestly, like when could you put together in your head the symptoms for an overcharge and an undercharge? Like all the little, like you knew that it was like on a fixed orifice on an undercharge system, you have low suction, high superheat, low subcooling, low head pressure, low temperature split, low compression ratio, whatever, all those little variables. How many years was it before you could just spout some of those things
Oh
off?
gosh, it would have been at least, I think, 5 years before us to that point.
And I would say today, I still don't even second guess myself. There's what I think is going to happen, and there's what actually happens. Because if you were to like go in my lab in the back of measureQuick, like we had a customer the other day saying, "Hey, I got a fixed orifice and it was the wrong size, and your software didn't pick it up, and I should have." I put all the data in for what I thought would happen, and it didn't pop up fixed orifice. So you know what I did? I go out in the shop, pump down a system, take out the orifice, put in the oversized orifice, and I missed one variable that happens with a fixed orifice when it's the wrong size, which was you have no subcooling basically, because when the orifice is oversized, the refrigerant won't back up in the condenser. You end up with really low superheat, end up with high suction pressure, a low head pressure, no subcooling, and then you can have normal superheat because you're sitting there charging it, you're adding gas, so you get the superheat right in the right range, but it's really flaky. Like the superheat can be, you just add a tiny bit of refrigerant, it goes from high superheat to almost no superheat. It's because that orifice is way oversized, so it's temperamental. But I missed in my brain for whatever reason. I just forgot that I was going to have the low subcooling. What didn't forget? measureQuick. The software didn't forget. I'm trying to put data in by hand, and the software picked it up right away. And I don't care how many years of experience. If we're to deploy 9 probes on a system, when the system stabilizes, can you tell me what the problem is? You think any technician could? Probably not, right? But measureQuick can. How do you think, from your opinion, today, if we're going to take somebody with skills, like we talked about, the guy from Xerox or whatever, what are the downsides that you see, or are there downsides to starting off with target zones versus knowing how to calculate the target? Is there a downside to that?
And to answer about bringing somebody in, I think this is an important part. We all look for shortcuts. We all look for things that can get our job done faster. And that's where these rules of thumb came in. The 20-degree delta T, it's false, right? There's a whole lot more goes into that, but it's just like people got comfortable. It made it fast. Superheat and subcooling pressures, these things that get fast, made it comfortable. Horribly inaccurate, worked enough. And the problem is now you're bringing more information. Hey, you can get these numbers more accurately, and you can still do them faster than you can do it with paper. Well, now you're looking at people having to change. You're having to change somebody's mindset. Right now, we have a new refrigerant coming out, R32 and 454B, and trying to tell people that it doesn't have propane in it they just refuse to understand it. They refuse to even accept the idea of something new. So one of the problems that we see in industry is trying to teach people that don't want to learn. So you're trying to show them that, hey, let's look at that bigger picture. They don't want to see it. So what is your solution? You have to bring in somebody else that's open-minded to it. And if you bring in somebody that has mechanical aptitude, they have skills where they can work with hand tools, they can understand safety, climbing ladders, they understand how to take parts and put parts back on, they have those mechanical aptitudes, and then you can give them a tool like measureQuick. Now they're open to looking at that bigger picture. Now they're seeing more, and now you can do more with that. And there are lots of techs out there that are using measureQuick, starting to really appreciate that bigger picture. But there's a lot of them out there that just, nope, if it's not beer can cold, they don't want to hear anything else different about it. And the problem we have is things are changing, whether you like it or not. There was mechanics that only worked in carburetors, and they're either working on only classic cars now, or they had to adapt. And now we're getting to VRV systems, variable capacity systems. We're getting two-stage systems don't have capacitors anymore. Those old ways of doing things are just not even available at all. So it's like at some point you have to realize you're gonna have to adapt or retire out. And a lot of people, because there's such a need for people in our trade, they've been very comfortable in their job. They don't have to adapt because we still need them. So what do you have to do? You have to look outside the box. Hey, if I can't get this person to look at the bigger picture to solve these other problems, I'm gonna have to look at someplace else. And that's where you start bringing either younger people in or people from other careers into our trade. And I don't think that's a bad thing. I think it's a good thing. I'm always learning new stuff. There's been many times where you've written an article or said something, and I'm like, man, that goes against everything that I was taught. And I had to open myself up to learning and seeing how. And this happens to me still today, whether it's Januak or Jenry Garcia. There's things that we're continuously learning, and then we apply that. If we're in a closed mindset where we refuse to learn, and then we're going to blame everything else. Oh, it's this junk new equipment, or, oh, it's these junky apps, blaming everything else instead of saying, hey, let's open ourselves up to see. Let me go try this out. Let me go look at those bigger pictures. And if somebody's not doing that, then we're forced to go outside and bring more people in.
There's a couple things that you made me think about right now. One is beer can cold really got eroded when we started bringing in imported beers. And it was all domestic, and it was went 45 degrees, the mountains are blue. You could literally peel the label off the Coors can, wrap it around the suction line, and charge it till the mountains are blue. But now that we're bringing in stouts and lagers that are served at room temperature, the American hand has gotten very confused. And these guys no longer know what a beer can cold is, because you hand them a beer and they're like, it could be a stout and lager, domestic, and that skill set's just been completely eroded.
Even back then, it wasn't good. It was so far-fetched and ridiculous. Yeah. I tell people, you can find an old school tech, he can walk up that system and he can feel things and adjust things, and he can get that system where it works. But I tell people, if you had a car without a speedometer, eventually you could get a pretty good idea of how to get where your speed is. You could get an idea. With a broken speedometer, drove it for long enough to get a pretty good idea. Now, get into a different car. It's not going to work anymore. Or try to tell this person that's coming in how to drive the car without a speedometer. Wouldn't it just be easier if we looked at the speedometer and compared it to the speed limit? I just think that makes sense to me.
Yeah, and we had somebody in the chat asking about Superheat and Subcool, and that goes back to we're trying to train technicians now on blends, and you got to know whether you're using dew point or bubble point. Yeah, and so measureQuick actually calculates midpoint of the refrigerant. A lot of people don't realize that because they go, oh, you're not measuring it right. You got to remember Superheat is use dew point for superheat, and Subcool is bubble point for subcool. It was just a little quick way. I can't take credit for that one, but I think it was maybe Brian, or at least paired it at one point. But again, with measureQuick, we don't have to do that because the software is doing that stuff for you. If we can focus on teaching probe placement, and here's one thing that I tell you is probably my biggest pet peeve is I get on like tech support, and I had a guy call me yesterday. He goes, I put the return air probe, just set it down by the thermostat, and where's the return air? What's on the second floor? And it's got both returns are on the second floor. And explain this to me. I'm like, okay, you got to put the return air probe at the return, because it could be 5 or 6 degrees hotter up there, and all the software is doing all the calculations based upon the probes being in the right position, so we can actually tell how the system's working. And if you go and put the probes in different places where it's expecting them, it's just you swapped around the suction and the liquid line. The other thing we didn't really talk about is the ability to stream data, right? Today, you need to go do tech support for a guy. You're either on the phone going, what's your pressure? What's your temperature? What's your superheat? And then you ask the guy, what's your superheat? He goes, oh, it's 10. You go, really? What's your suction pressure? Oh, it's 138. What's your liquid line temperature? Yeah, what's your suction line temperature? It's 47. Okay, that's not 10 degrees of superheat. Why'd you tell me 10? That's because I thought what you wanted to hear, right? And you have no idea. I know this is a fact because I've done tech support with guys on the phone. I had one yesterday. A guy was telling me, he goes, these targets just don't seem right. This diagnostic doesn't seem right. I said, you know what, just stream the data so I can look at it. He streams the data, return error and supply error, put over backwards on the piece of equipment. Took me 2 seconds to figure out what was wrong. But all of his targets were being calculated based off of the software thinking it's 55 degrees outside and 75 degrees in the supply air. And it's like, yeah, you have an inefficient compressor or whatever is coming up with some weird diagnostic. And it's like, as soon as he flipped it around, it's like, oh, a lot better now. And I have him touch a button on an app and stream the data. I don't have to ask him anything. I know what probes are deployed. I know so much about how that system's operating, and I don't really have to ask all those questions and hope I'm going to get a right answer.
I've done tech support and I like to be able to help people, but it's so frustrating because you're asking for numbers and they're giving you good. Good is not a number. Like, I need data to go on, or they'll just make up numbers and give it to you. And it's so frustrating because I can't help you if you don't give me the numbers. So I love it when people send me information from an app that gives me actual numbers directly. And there's a lot of apps out there and people will send me information. I start asking them for more information. The app gave you everything. I'm like, it didn't. And I had to go through line by line and compare everything in my head to know that I need more information. And when I look at a measureQuick chart, I can look, everything's right there in red or green, so they can do the data logging. You can see what's changing. And I'm able to diagnose things so much faster for people, and I can give them those answers. And here's the big thing. Once people start asking me questions for measureQuick, it's only 2 times at the most, because by that 3rd time, they're realizing they can just use the app and it diagnoses it for them.
A lot of times they just don't know how to navigate it.
Yeah, that's right. And it is. There's a lot to it. There's a lot of numbers people aren't used to looking at. But for me, being a very visual person, I can look at those and diagnose it quickly. And also, I used to do some consulting work, and I'd go out to a company and I could hook up all my probes. I could give them a report. Here's what the problem is. They fix it. I redo it again and show that everything's in the green. The homeowner doesn't know what all those numbers mean, but they do know what green check marks are and green graphs are. So they don't know who I am. They don't know my reputation, but here's somebody that came in. They gave them a report. Here's before, here's after. Now they're thinking, wow, that's really impressive. And then the company says, couldn't we have just done that ourselves? Why do we need you? I'm like, you can do it yourself. And then they start using it. And then I don't have to go back there. It's embracing that technology. We could fight it, but we could embrace it and make our jobs easier, more accurate, and also faster.
So how many problems do you think you missed using old school ways of doing work versus what you would catch today if you were to just put 9 probes out on measureQuick and let it assist you on the diagnostic?
Lots and lots. It wasn't until I started working for a compressor manufacturer that I really truly understood the importance of discharge temperature. And the only app I know that actually monitors that discharge temperature. You could have everything working really good and that discharge temperature is too high. You have an oil return issue and nobody else is looking at that. Hey, we could lose the compressor because of oil return. So knowing the importance of monitoring that discharge line temperature and see what's happening, the air temperature, not just the outdoor temperature, but the temperature of the air coming into that coil, airflow issues, being able to actually monitor before I could calculate the latent capacity, but it took time. I have to actually sit down and actually do it. Now I can just do it for fun. I can just see right there in the app, hey, you're removing this many pounds of water every hour. Wow.
And how many gallons
that's
too?
Cool. Yeah. It's that, if nothing else, it's fun. We can also use that if we're in Florida and we can see that, hey, we're not moving out much moisture, but it feels good, right? We can start looking at and seeing, hey, let's start addressing this issue. I had one house that the company had installed everything great. The customer's unhappy because the humidity was high. I go out to the house. We found out we were able to measure how much moisture we're pulling out. Said, hey, no, your system is dehumidifying. The sizing is right. Your airflow is good. Here's the data to prove it. Something else is going on at the house. So we found out, I started using moisture meters and found out that they had a leak under the slab. And that moisture was coming up through the concrete. And that's what was changing their instruments. But the customer blamed the equipment, but I had the data that said, hey, the equipment's good. Let's look outside that box. And then we're able to solve the problem. The customer was super happy. Company was happy. Like I was the hero, right? And so everybody wins. Like it was really great. But it comes from having that data and be able to interpret it quickly.
Yeah, I had one. I was out with a company in Nashville, and they called me. They're like, "Hey, we're thinking about using measureQuick. We want you to come out and just ride along with our guys and see what you can do." So they didn't realize they were jerking me around. They were sending me to a bunch of problem jobs that they had that they couldn't figure out. They were going to see if we could figure it out with the software. So I get out to this lady's house. She's got a historical home and it's got hardwood floors in it and it's just gorgeous home. But she's got a dehumidifier in her living room and a dehumidifier upstairs. And this house is just wringing wet with humidity, completely uncomfortable. And she's not happy. They got 4 tons downstairs and they got 3 tons upstairs. It's a fairly decent sized house, but the systems are probably a little bit oversized. And I go up there and I'm like, yeah, we've tested everything and we can't find anything wrong with the system. We got the airflow set to 350 CFM per ton and they're going through this whole thing and with me. And I'm like, okay. So I deploy the probes in measureQuick and the first thing it picks up, because it's got like really high suction pressure, it picks up, it's got potentially has duct leakage. So I'm poking around the attic and I literally put my hand through this insulation. There's a hole that's about 6 inches in. It's a triangular shaped hole, but it's probably 6 inches. We patched the hole up and it comes down a little bit. And I'm like, are you sure? I said, our software is saying and it was a 3-ton system. And I said, our software is picking up, you're like doing 1750 CFM of airflow. And they're like, oh no, it's at 350 CFM a ton. I'm sure of it. And I'm like, okay. So, but our software is picking up this high airflow. And I said, you know what, just let me check it. And I popped the cover off and sure as heck, it's set to 350 CFM per ton. Then I glanced at the other 2 dip switches and I realized it's a 5-ton drive and it's set for 5 tons at 350 CFM per ton, not set for 3 tons at 350 CFM per ton. So I flipped it over to a 3-ton drive and the fan slows way down. We're standing up there and this thing's pulling 19 pounds per hour of water out of the house. It's just an insane amount. I don't know if I've ever seen so much water. We're probably up there for about 15 minutes. I'm explaining to their service technician what latent load is and sensible load and why at that point, the temperature splits like 11 degrees or something. It's like all the energy's going to removing the water from the house. And all of a sudden the lady downstairs screams, what did you guys do up there? What are you doing? And I'm thinking that there's water like running down the inside of the house. And she screams, those humidifiers just shut off. They've never shut off in the summer ever. I will guarantee you they had 14 different technicians out there to look at the system. And nobody caught these fundamental things like the duct leakage and the high airflow because they had no tools to measure airflow. They were relying on the dip switch settings. They missed the 5-ton drive on the 3-ton system. They missed the duct leakage issue. And they had no tools to tell how much sensible they were doing, how much latent they were doing. And the technician ended up buying a set of smart probes from somebody ordering. Literally while I was standing there, he's ordering his things from whoever he was getting them from at the time. But that's the difference. I'm sure they had the subcooling right. I'm sure they had the superheat right. But that piece of equipment was not doing near what it was engineered to do. And they had great mechanics, but mechanics can't always fix things when they're technology problems. This was a math problem. This was your ratio of sensible to latent is incorrect. Your airflow is incorrect. And until we had something to actually show them that in real time, this didn't remove the mechanic, like measureQuick. I didn't push a button on measureQuick and say auto adjust the airflow. I didn't say fix duct leakage, click button, duct leakage is fixed. I still had to have somebody come in. Now we taped it up temporarily, but somebody came in and put a sheet metal patch on an insulation or whatever they did on the ductwork. And we flipped the dip switches on the equipment and got the airflow set correctly. But it still requires a technician or a mechanic to fix the problems that the software picks up. So these tools aren't going to replace you. Just like an OBD2 port on a car didn't replace an auto technician. It just enabled them to solve very complex problems exponentially faster, right?
The other day we had a show about using a plasma cutter for ductwork for the fittings, and they could lay everything out. The computer program was put all the information in, it laid it out in the metal, cut everything out. And that wasn't replacing somebody's job. You still had to have somebody setting that metal up, working the machine, bending it, but now it was a lot more accurate, a lot faster, able to do more with it. And I just thought it was really cool to be able to do that. So the technology is coming, like whether we like it or not, it's here. We live in a digital era. So we're working with digital, like the ECM motors. It's a computer you're working with. Why not just embrace the tools that can make our jobs easier and more accurate? Right? So easier and more accurate. So we're winning.
So let's talk about, because there's some questions about the 9 probes that we put on a system because we got 10 minutes left. And we know that most systems have incorrect charge and airflow. So the first time out, we always recommend that you hook up a set of pressure probes. And so you have a high pressure and low pressure. You have a suction line temperature and liquid line temperature. And then outdoors, we also have outdoor air temperature. And it's really important that you measure outdoor air temperature near the bottom of the condenser. We pull weather from a weather station and measureQuick, but that's more of a data compliance tool. Like when we get a utility that says it needs to be 70 degrees outside before you test the system, we pull in the weather data for the utility so they know it's 70, and then they're expecting to see the condenser entering air somewhere around 70. But if you're on a rooftop unit, or depending on the color of the soil, or if you're near blacktop, that air could be 70 outside, but you could be pulling 75 or 80 degree air into your condenser because surrounding air isn't representative of the air entering condenser. We got high pressure, low pressure, suction line, liquid line, and we got outdoor air temp. Then inside, we're measuring return air temperature at the inlet to the return. measureQuick test from inlet to outlet. Because here's another thing that's important to grasp is just because we're producing the right amount of cooling at the equipment doesn't mean that we're producing the right amount of cooling to the home or getting that cooling in the home. Air leaks are huge problems. So we measure at the return air inlet. You could have 75 degree air entering the return air inlet and 87 degree air entering at the blower wheel because we're pulling air from 140 degree attic. The software will pick that up because it's going to see, it's expecting target pressure based on the 75 degree air, but it's getting 87 degree air. So it's going to see a low temperature split. It's going to erode the temp split, and it's going to have higher normal suction pressure. And so the software will use things like that to pick that up. Then obviously we're close to supply. So we want to be 6 to 10 feet away from the evaporator, not a lot of sight, but we want to give time for the air to mix. So we have indoors, we're also measuring return air static and supply air static. We recommend measuring those separately. That's why we talk about 9 probes, because we're looking at return air static so we can determine if there's static pressure issues on the return side, the supply air static so we can see if there's static pressure issues on the high side, and then we're calculating total external static. And then we're also, one thing, if you use measureQuick, sometimes you'll see that the static pressure, like if you do the calculation by hand, you go, what the heck? The measureQuick's calculating static pressure wrong. And that's because we also adjust the static pressure for the air density ratio. When we're looking at static pressure that is given to you by a manufacturer, that static pressure reading is tabulated from standard air. And so if your air is not standard air, then you're going to get your static pressures will actually vary, and we correct it back to standard air pressure. So if you're using a static pressure chart, let's say in Denver, it might read 0.6 inches of static, but it's equivalent to 0.75 at sea level. And so it's really important to understand your air density ratio when you're sizing a fan. Now, again, there's people online that go, who the hell cares about all that stuff? If you care about setting up equipment correctly, and you care about the measurements you make, and you care about delivering the capacity and the efficiency, and you care about not creating callbacks, and you care about being able to do things right the first time, and you care about your customers, and you care about the environment, and you care about energy efficiency, then yeah, that would be me or you, right? If you care about that kind of stuff. But it's those 9 probes are really critical. But in your experience, you've taught a lot of young people, you taught a lot of people. How long do you think, legitimately, how long do you think it takes somebody to teach them to get from 0 to home base on measureQuick, to actually be able to use it and be productive? What would you say?
There's a big difference between people that have some mechanical aptitude. It's already understands hooking up an airflow, where to get these numbers. If somebody already has that basic to understand what return air, supply air is, those kind of things, it doesn't take that long. It does take a lot longer from somebody that's fresh, that's never done any of it before, getting them to understand the term return air, the difference between return air at the coil versus at the vent. Some of these things, it takes a little bit longer for them to get there, but I find better results with that than trying to get somebody to change their mindset to now deploy these probes, even though they know all these terms, trying to get them to let go and actually trust the equipment a little bit. It's faster to bring somebody else in.
Yeah, it's funny because the program I taught was a 2-year vocational school program, right? I think it's always interesting if you break it down into hours, right? I had 3 hours a day. I taught the kids, and I taught them 250 class days a year. It was 1,080 hours a year if the kids never missed a day. And And I never had any extracurricular activities, any field trips, any school functions or anything like that, or any winter days that we had off because of whatever. You probably lose about 10% of your time in a school district just to crap that you have to do day after day. So now if that 1,080 hours, we can take 100 hours off probably to lost during the school year. Now we're at 900 hours. There's 2,080 hours in a work year. So even though it's a 2-year program, it's realistically it's less than 6 months of on-the-job training. And so how far do you think your students were in any class you taught? Did it take them 16 or 20 weeks to learn what return air and supply air were, or what a suction line or a liquid line was,
No.
or or what a condenser was and an evaporator was? You think about it, in about 40 to 60 hours, I could take somebody that has zero air conditioning experience and teach them the fundamentals, right?
Yep.
For crying out loud, we can give somebody a language program called Babbel and teach them how to speak Spanish in 8 to 10 weeks. And I don't think speaking Spanish is probably any more complicated than learning air conditioner terms. They're both foreign terms, foreign things that you got to learn, but we can teach people this basic skill set and they can learn enough language to actually be productive. And now the other thing is with this is we have voice, we have video, we have text, right? Because my cell phone, I got FaceTime. I can text you, I can call you, I can stream the data to you. So support isn't like this giant thing. At least you and I, either we're the two craziest people on the freaking planet that think that you can actually train people and have them leverage software, or the rest of the industry is maybe scared for no reason that they're going to lose their jobs, which they definitely aren't. They're just going to generate more revenue and find more opportunities. Or people are just pigheaded and stuck in their ways that we got to continue to teach people the way they were taught. And I think, I don't know about you, but I learned when I was a kid not to touch a hot stove by touching a burner because, I was a freaking idiot and I touched the grate after my mom shut off the burner and I burned myself. I don't tell my kids, yeah, go ahead, son, see what happens. Go ahead, because I want him to learn from my experience. I'm like, dude, don't do that. You're going to get burned. And so why would we abuse new technicians coming into this industry to make them struggle the way that we struggled when we can provide them with software and a solution that's going to actually make this job enjoyable? Because that's the other thing. How much more fun is it, do you think, just closing this up? How many things did you learn when you used measureQuick for the first couple of times? How many relationships do you think that you learned? Like all of a sudden the lights came on and you finally understood how all this stuff worked together because you saw everything happen at once. You saw stuff moving in and out of target zones. You saw the impacts. You saw the capacity change. Tell me that doesn't change your entire career. Like if you've been doing this for 20 years and all of a sudden you see all those fundamental relationships in real time, what did that do for you as a teacher, as an instructor, as a person? What did that do for you when you started using software and you're
Oh,
visual? What?
it was great because I could do those things by math. It took a long time and only did it when I had big problems, but now I could get all that stuff instantly on the fly, see the changes. And it was cool to be able to, hey, let's cover up the condenser and just see what happens. And you're seeing everything change. Before we had experience, hey, if we did this is what's going to happen. With measureQuick, you can become like a scientist. You can have a piece of equipment and you can cause a problem and you can see how it affects everything in the system. And that's cool.
And a lot of times, I don't care how experienced you are. I've got 40 years of experience and I still learn stuff every day. Going back to that stupid fixed orifice thing, I just forgot one variable and what would happen. And it was thrown off the whole computer program. The computer knew it, but I didn't know it. And these things are not easy. And then if we have multiple problems, how many times do you think we have an airflow issue somebody tried to resolve with refrigerant charge,
All
right?
the time.
These charts, these little up and down arrow charts, they don't cut it. Those people don't realize that those charts are based off a properly charged system that they increased or decreased the airflow, or a system with correct airflow that they increased or decreased the refrigerant charge. It's not based upon the system that has a dirty condenser, low airflow, an undercharge, and whatever else is wrong with it. measureQuick will pick those things up because it uses the way the logic works in it. It just uses a whole different set of tools. It's But the moral of the story, I think we got to change the way that we're approaching the industry. We try and do this electrification and we don't leverage technology and we just continue on the path. I've been doing this for a lot of years. In your opinion, can we bring people in fast enough without leveraging technology, doing things the way that we've always done it? Can we bring them fast enough in to meet the industry demands?
No, especially with the gatekeeping and learning. No, you have to do this job this way because I had to do it 30, 40 years ago. And then if you do it for long enough, then I'll start telling you my little secrets, which are also out of date. No, it's not possible. We have to leverage technology. And I love my tools that I started with, which are now, it pains me to say, classics or antiques. But I love tools. So I still have my stuff, but digital, the new generation, they grew up with digital phones, digital computers. They grew up in a digital world. That's their natural habitat. So giving them tools that they naturally understand and naturally know how to use and empowering them with all this
Yep.
information that's available. But why would we not? Why wouldn't we?
Yeah, because someday, Ty, you may get stuck in a phone booth with a rotary phone, and what are you going to do when you don't know how to make a phone call? For crying out loud, that could happen, right? First, you got to find a phone booth, and then second, you got to find one with a rotary phone. But if that happens, you are absolutely screwed. You're not going to be able to call your mom or anything.
You're right. Yeah. Better learn how to use that. Oh my gosh. Yes. And smoke signals. Because you never know if the phone's out. You're going to have to do the smoke
Yeah.
signal.
Oh, yeah. Yeah. Yep. So, well, anyway, we're at time, so I don't want to hold you on any longer than normal. But thanks for coming on. This was fun to discuss, and hopefully we get some good views off this with some of the people that were so anti-technology. Maybe we changed their mind. Maybe we just drove them further into the holes that they're in.
I'm not worried about changing them. I'm more worried about, hey, if we can inspire other people that do want to change, we can inspire people to maybe adapt to bring more people into the trade and then ultimately inspire bringing more people into the trade. They're saying, hey, I like technology. I like working with my hands. I could see myself doing that. Let's bring people in, fresh blood into the trade with some ideas and look at the whole house problem and solve more problems.
Oh yeah,
Technology is here.
Yeah, and it's so much easier than it's ever been with stuff like conduit software to measure heat load calculations, true flow grid to measure airflow, and measureQuick to do the refrigeration diagnostics. And I mean, there's so many great products out there. We're at just a crazy good time for technology. We just got to get more people to embrace it and not fear it's going to take their jobs away, because technology may solve the problem, but we still got to have a mechanic to actually make the repair. And that's really what it comes down to. Hey, thanks for joining me on this. And it was fun. I'll catch you at ESCO maybe this spring.
Sounds good. Looking forward to it.
All right, Ty.